Welcome to the voiceover PowerPoint for research methods and a brief talk about systems. The following slide will have a brief video on research and experimentation in psychology presented by Crash Course. And then the remainder of the voiceover will contain components of research and systems theory that I think that it's very important for you to get. Well, now that you've enjoyed the video on the crash course in psychological methods of research, first thing I want to talk about is systems. Everything's part of a system. Remember earlier in one of our other PowerPoints, we talked about the different paradigms that we use to study the different psychopathologies. Each of those paradigms has its own system. And it's important for you there's a couple of basic things to remember about a system. Everything is part of a system. What is a system? It's a group of interacting, interrelated, or interdependent elements that form a complex whole. So you think in terms of the solar system, the respiratory system, a weather system. These are all systems, okay? How many systems are there in your body, in your family, in your community, and especially in your psyche, okay? There's systems everywhere. And understanding that something is part of a system keeps you from separating it and just trying to deal with it on a very specific basis. It's like in a hospital, if somebody has a broken leg, you don't refer to the patient as the broken leg. They should be referred to as the person with the broken leg. In psychology, we look at not just systems, but a dynamic systems perspective. Dynamic means movement. There's energy, there's motion. One thing affects another thing, affects another thing. It's constantly changing. There's always activity and progress. Very rarely does a system stall. A couple of things to remember. Systems proceed without predetermination. They emerge and become increasingly complex. So when you think of emerging, think of like an acorn turning into a tree and blossoming. Think about a caterpillar going through metamorphosis, becoming a butterfly. It emerges from the cocoon. It doesn't just happen. Okay? Now, during times of challenge and instability or stress, systems reorganize. They try to adapt, adjust, and modify. And the larger a system is, the more likely it will become self-sustaining. So think in terms of something like the IRS is a huge system. Yes, there's somebody that runs it, but it pretty much would run on its own. Think of your body when it's when it's attacked by a virus or a bacteria. It tries to heal itself before you ever do anything. It is self-sustaining. When a system experiences a challenge, focusing on the obvious symptoms and not the underlying causes produces short-term benefit, long-term malaise. In other words, it's a Band-Aid fix. If you just look at the obvious symptoms, it's like putting a Band-Aid over a bullet hole. It doesn't do a whole lot, okay? You can't hold the egg together with Band-Aids. It may stop the bleeding for a moment, but you've got to think it through, and that goes into thinking about the research. Now, not only do you need to get to uh, the underlying problem, uh, or you just have a band-aid effect, then the other thing you have to recognize is what is referred to as the butterfly effect. That gets its name from if a butterfly flaps its wings in Africa, it can cause a tsunami in America as that builds, that little bit of wind builds over the ocean. So there, a small change in a system can cause a huge change in in the system down the line. Okay, it's like think of a car, a race car. It loses a bolt, uh, and after a while, the whole car ends up falling apart. Uh, and then that system impacts another system. This is incredibly obvious in the politics of the day. Nothing is isolated. So one of the dynamic systems that will keep getting referred to in developmental psychology is the ecological systems theory. So if you look at the image, then you see that the microsystem is the stuff that impacts the infant right around them. Then it moves into the mesosystem, which is the next layer, and then the exosystem and the macro system. And all of these things impact that micro system. Okay? And then along with that, you have the chrono system, which is time. And time impacts everything also. So all of these things work together and against each other. And this is what makes systems theory so important to understand, and the idea that this is all complex. There is no one way a child should be raised or could be raised that's going to guarantee everything comes out all right. So you have to keep the systems in mind, even though as we start talking about individual research, individual concepts or theories, that none of them answer all the questions. Okay, so now we're going to shift gears and talk about the research methods. I know from all your background and other courses that you've had, you know what science is. You should know what a theory is. You should know what a hypothesis is. So we're talking about the scientific method. You start with a question, you do research, you form a hypothesis, you test it, you analyze and draw your conclusions, and you reject or refine your hypothesis. Okay, observation, you come up with a question. Remember, research is all about the question. Okay, if you don't have a good question, you're not going to have a good research project. Question, you form a hypothesis, you make a prediction, you test it, doesn't work, you go back and reform your hypothesis. Eventually you come up with a conclusion and you communicate your theory. The ones that are used the most are the case study and the correlation. A real experiment is used somewhat, but it's not. It's more used with pharmaceuticals, where they can control the environment. You know, one social psychology experiment is the marshmallow test, where you have like 4-year-olds or 6-year-olds, and you tell them if they sit there for 5 minutes with a marshmallow in front of them, they can then have two if they can wait that long. And then you see how many of them can wait, and then you see how they act down the line. The two big ones you're going to be most familiar with are the case study and correlational method. So the case study is just a detailed description of an individual, all the stuff about them, everything that's involved. It can usually help to disprove a hypothesis or generate a hypothesis. It's limited because you can't rule out, there's no way you can prove it. Okay, it's a study about what happened. Now, if you get several case studies showing the same thing, then that helps develop more of a hypothesis that can be tested in other ways. One way to provide a case study, and by the way, case studies don't have to be about just an individual. They can be about a group. So one way of doing case study is by observation. Obviously, it should be systematic. Okay, so one way of doing observation is naturalistic observation. So you want to find out if boys are more aggressive on the playground than girls. So you sit out and watch recess every day for a month or a year, and then you present your case study by the number of times that the children got in fights. Or you could have much more structured observation, similar to the marshmallow experiment I was talking about before, or say object permanence. You'll be reading about that soon. Another method is by using self-reports. These include surveys. You can have a clinical interview where you get in deeply into what's going on with the person, or a structured interview where you ask every participant the exact same question and don't give them any extra help. If they say, "What does this mean?" you just repeat the question. So those are both self-reports. So another favorite method to devise a case study is looking at ethnography. And that's when somebody gets embedded in a community. So you normally think of this in terms of anthropology. So if you go live amongst a certain group of people to determine how they live, how they do things, and then you report. Now, you can't generalize that to everybody, and what you have to keep in mind is that your being there impacts them. So that's one of the big arguments against ethnography. The correlational method is very widely used in psychology overall. Below are two actually social psychology questions. What is the relationship between pornography and aggression? What's the relationship between the amount of violent television children watch and how aggressive they are? These are good questions, and they're usually defined by a correlation. Usually there's a y and an x axis on a plot, so as you measure these things, for example, the people who experience more stress have more headaches. Doesn't determine cause or effect. There's a positive correlation and a negative correlation. The positive correlation scores high on, the higher the scores on the x axis, the higher the scores on the y axis. In the negative correlation, the higher the scores on the x are associated with lower scores on the y. So if you look at the two plots, you see the one on the left is a positive correlation, the one on the right is a negative correlation, and of course the one in the middle is there's no correlation. So when you're looking at studies, at research studies, one of the things you want to pay attention to is the correlation coefficient. That's usually shown by the initial R, and it'll vary from a -1, which would be a negative correlation, to a +1, which is would be a positive correlation. Make sense? The higher the absolute value, the stronger the relationship. So a positive correlation If there's increases of one variable, there's increases in the other variable. For example, height and weight are positively correlated. Taller people, taller people weigh more. Okay, they are positively correlated. A negative correlation, the increase in one variable is measured with a decrease in another one's. Vaccination rates correlate negatively with disease rates. Okay, it doesn't have anything to do with good or bad or right or wrong. And the more people get vaccinated, the less often they get the disease. Make sense? And always remember, correlation does not equal causation. So when you're having studies, when you're looking at studies, one of the things that we look at is the statistical significance. So whenever you're talking about a study and they ask if is the correlation significant or are the findings significant, we're looking for a statistical significance. Okay, and that's usually equal to or greater than 0.05. Those are statistical terms, and when you take your stats course, if you haven't already have it, you'll learn how to do that. But clinically significant findings are also statistically significant. I can talk. So when you're having studies, when you're looking at studies, one of the things that we look at is the statistical significance. So whenever you're talking about a study and they ask if is the correlation significant or are the findings significant, we're looking for a statistical significance. Okay, and that's usually equal to or greater than 0.05. Those are statistical terms, and when you take your stats course, if you haven't already have it, you'll learn how to do that. But clinically significant findings are also statistically significant. I can talk. When you're looking at an experiment versus a study, there's always random assignment. We look at the independent variable. That's what can be manipulated or what you can change. The dependent variable, which is what you measure. So if you're talking about how much water comes through a faucet, I measure it for 1 minute with the valve 100% open. I measure it for a minute with the valve half closed, and I measure it for a minute with the valve open 10% and see how much water goes through. And then we can see whether there's a difference between the two groups and evaluate something from that. But you need to know that there's always, if you have an experiment, it's random assignment, independent and dependent variables are critical. These are the type things we look at. Placebos, as I said, the experimental research usually has something to do with psychopharmaceuticals, drugs to treat the. How do we find out from all these different studies what's going on? That's a meta-analysis. So you're looking at a whole lot of studies that you look at. So, for example, down below that shows Smith and his group looked at 475 outcome studies involving 25,000 subjects, and they came up with the concept that psychotherapy is effective. Okay, because it was statistically significant that the outcomes were positive more than negative. Make sense? Now, just a cautioning remark. First off, always be a skeptic when you hear things, and that doesn't mean being a cynic. It just means you question it. A real scientist never proves anything. They say the data suggests, the study indicates. If you see something that's clinically proven in an advertisement, you know that's coming from the advertising and marketing people and not from the scientists. Okay, you have to be aware of fake news. Uh, People, there's just seems to be an epidemic of people just making stuff up and putting it out there and making it seem like because it's on the internet uh, that it's news. And then what happens is you have someone on a news show, Fox News or CNN or NBC or somebody else picks up the fake news and says it's been reported that, in this case, Pope Francis endorses Donald Trump for president. And then somebody else reports on that report. And before long, people think that it really happened. So just be a skeptic. Look at things and say, okay, what's the basis for this? And then finally, there's a YouTube video in the folder from the old sitcom Friends, where Ross and Phoebe are talking about evolution and the scientific method. And for that reason, I think it's a pretty good example of why you need to be skeptical. So I hope that brought a smile to your face. But as we move along, also remember finally that uh, if you're doing research, your participants have rights. And the first one is protect them from harm, and then they have to have informed consent. Okay, you'll learn more about that as you move forward uh, in your major. So as we move into the course, the things I want you to remember, first off, is that correlation does not equal causation. It can, but most often does not. And a whole lot of uh, developmental psychology research is correlational. In science, we prove nothing and always remain skeptical. Just because it's published on the news or YouTube or Instagram or whatever doesn't mean it's true.